A galaxy can hide its greatest secrets in plain sight. The majestic spiral of NGC 1300 is one of the most photographed islands of stars in the cosmos, a textbook example of a barred spiral galaxy. But behind that iconic beauty lies a reality far stranger than any picture can show. By staying until the end, you will journey through 25 of its most baffling phenomena, each one a cosmic puzzle that reshapes what we thought we knew. We will explore a central black hole that refuses to feed, phantom arms etched by ancient violence, and stars flung from the galaxy at impossible speeds. What does it truly mean to look at a galaxy and realize we are only seeing the surface? The heart of a galaxy should be a place of unimaginable violence. At the core of most spirals like our own Milky Way, a supermassive black hole feasts on a swirling banquet of gas and stars, a cosmic engine blazing with light. But NGC 1300 holds its first major secret right at its center. Phenomenon number one is the supermassive black hole that simply refuses to roar. Observations reveal a core that is suspiciously dark and quiet, a sleeping giant where astrophysicists expected a brilliant beacon. This is not a missing black hole, but one that is strangely dormant, defying the standard models of how these colossal structures interact with their galactic homes. So what is starving this cosmic beast? One compelling theory points directly to the galaxy's most famous feature, its magnificent bar. That bright band of stars and gas cutting through the center may act like a cosmic traffic regulator. Instead of funneling material inward to feed the black hole, the bar's complex gravitational forces could be redirecting the gas, keeping it in a stable orbit around the outskirts. The black hole sits at the center of a feast, yet remains on a forced diet, isolated by the very structure of its galaxy. Another possibility is that we are catching it in a brief, quiet chapter of an immensely long life. Black holes are thought to cycle between active feeding frenzies and long periods of dormancy. NGC 1300's core might simply be in a deep sleep, gathering its strength for a future outburst that will reshape the entire inner galaxy. This quiet core forces us to rethink a fundamental relationship. We assume the bar fed the beast, but here it may be the beast's jailer. Understanding why this black hole is so still helps us piece together the life cycle of all galaxies, revealing that the most powerful forces in the universe can sometimes be rendered silent by the architecture that surrounds them. This perfect equilibrium leads us directly to phenomenon number two, the bar that defies stability. That brilliant band of light slicing through the galaxy's heart is not just for show, it is a cosmic anomaly in its own right. While barred spirals are common, the bar in NGC 1300 is in a league of its own. It is exceptionally long and luminous, a rigid backbone of stars that appears locked in place over millions of years. Normally, these structures are dynamic and somewhat chaotic. Their immense gravity acts like a cosmic pump, violently funneling gas and dust from the outer spiral arms down toward the galactic core. This process typically triggers furious bursts of new star formation and feeds the central black hole, creating a turbulent, ever-changing environment. Yet here, the bar exists in a state of seemingly perfect balance. It resists the very forces of chaos and disruption that should be tearing it apart, or at least making it wobble and shift. So what is holding this colossal structure together? The leading suspect is an unseen architect, dark matter. Think of the visible bar we see as just the tip of a vast, invisible iceberg. Astrophysicists theorize that a dense, elongated halo of dark matter envelops the entire bar, acting as a gravitational scaffold. This unseen framework provides extra mass and stability, essentially locking the stellar bar into a rigid, long-lived configuration. It is the difference between a bridge built only of steel, which might sway and twist in the wind, and one reinforced with a deep, immovable foundation rooted in bedrock. The dark matter halo is that bedrock, granting the bar its extraordinary permanence. This stability has profound consequences. Because the bar is so steady, it may be regulating the flow of gas with unusual precision, which could explain the dormant black hole we just discussed. Instead of a chaotic feast or famine delivery system, it might be a smooth, controlled conveyor belt that currently keeps fuel in circulation rather than dumping it in the center. The bar is not just a feature, it is the galaxy's master regulator, and its unnatural stability points to the invisible hand of dark matter shaping everything we see. These ghostly imprints lead our eyes outward to phenomenon number 3, the phantom spiral arms. The sweeping arcs of NGC 1300 are its defining feature, but they hold a secret only revealed by the most sensitive observations. Beyond the bright, well-defined arms, astronomers have detected faint, wispy extensions and disjointed spurs of stars and gas. These structures drift like cosmic afterthoughts, failing to follow the galaxy's elegant spiral pattern. They are the echoes of an ancient story written in starlight, streams of material torn loose and cast adrift long ago. To picture this, imagine tracing the perfect spiral of a seashell, only to find faint, broken lines veering off into the sand around it. These are not part of the shell's current growth. They are fragments from a time it was jostled or broken. In the same way, these phantom arms are likely the scars of a past merger, the lingering debris from when a smaller galaxy ventured too close to NGC 1300. Billions of years ago, the immense gravity of the larger spiral would have reached out, not with a sudden crash, but with a slow, inexorable pull. It would have stretched the intruder like cosmic taffy, stripping away its stars and gas in long, looping trails that never fully rejoin the main galactic dance. Over aeons, these trails faded, becoming the subtle, ghostly structures we now detect. They are the fossilized evidence of a meal consumed in the deep past. Another possibility is that they are the remnants of a massive gravitational tug-of-war, not with another galaxy, but within NGC 1300 itself. The immense bar at its center, that rigid backbone of stars, constantly stirs the galactic pot. Its gravitational forces can sometimes fling entire clusters of stars into chaotic orbits, creating these faint, trailing streams that orbit out of sync with the main arms. These phantom arms remind us that a galaxy is not a static painting. It is a dynamic, ever-evolving entity, and its history is recorded not just in its bright centers, but in these faint, forgotten outskirts. Every wisp of stars is a chapter in a billion-year story of collision and chaos, a ghostly signature of the violence required to build something so beautiful. These ghostly arms are not the only places where the galaxy's story has stalled. Phenomenon number 4 is a star formation desert, a vast and puzzling void of cosmic quiet. Within the bustling spiral of NGC 1300, astronomers have mapped a specific region, often along the inner edge of its majestic bar, where the chaos of creation has gone silent. This area stands in stark contrast to the galaxy's vibrant stellar nurseries, those glowing pink clouds of hydrogen gas where new stars are constantly being forged. In those nurseries, gravity pulls dense knots of gas together until they collapse, ignite, and begin to shine. But in this desert, that process has mysteriously stopped. It is a celestial dead zone where the gas exists, but refuses to coalesce into new suns. What could possibly suppress the most fundamental act in a galaxy? One leading theory points to a history of immense violence. A single, extremely powerful supernova explosion in the distant past could have been the culprit. When a massive star dies, it does not go quietly. It unleashes a catastrophic shockwave that races through surrounding space at millions of miles per hour. Think of it as a cosmic tsunami. This wave would have slammed through the interstellar gas in this region, not just pushing it aside, but violently heating it and scattering it. The force would have torn apart the delicate, cool clouds necessary for star birth, leaving behind only a hot, thin, and diffuse medium where gravity cannot gain a foothold. The desert, then, would be the long-lasting scar of a single titanic stellar death, a blast zone that remains sterile eons later. But there is another, more subtle possibility. Perhaps the culprit is not a blast, but an invisible field. Intense, localized magnetic fields could be threading through this region, acting like a powerful cosmic reinforcement. Gas clouds need to collapse inward to form stars, but strong magnetic fields can create resistance, providing a sort of structural support that prevents the cloud from condensing. It would be like trying to compress a spring. The harder you push, the more it pushes back. The magnetic energy keeps the gas agitated and spread out, forever on the verge of collapse, but never quite tipping over the edge. This starless region challenges a core assumption in astronomy that given enough cold gas, stars will eventually form. Here, the recipe is broken. The ingredients are present, but some unseen force, whether a past cataclysm or a persistent magnetic cage, has locked them in a state of perpetual potential. It forces us to ask, what other invisible barriers exist across the cosmos, quietly dictating where light can and cannot be born? The quiet deserts of star formation are not the only places where NGC 1300 keeps its most dynamic secrets. Phenomenon number 5 introduces the runaway hypervelocity stars. Within this grand spiral, astronomers have identified individual suns moving with such incredible speed that they are destined for a one-way ticket out of the galaxy entirely. These are not simply fast stars. They are cosmic projectiles, flung from the heart of NGC 1300 with enough velocity to overcome the gravitational pull of billions of suns. To escape a galaxy's grasp requires a truly cataclysmic launch event, and the prime suspect sits at the very center we just explored. The most likely origin story is a brutal gravitational dance involving the dormant supermassive black hole and a doomed pair of stars. Imagine a binary star system, two suns orbiting each other, that drifts perilously close to the galactic core. The black hole's immense gravity violently disrupts their partnership. In a flash of cosmic chaos, one star is captured, pulled into a tight orbit, or even consumed. Its partner, however, receives the full slingshot effect of that interaction. Like a stone from a giant's catapult, the surviving star is hurled away at a significant fraction of the speed of light, now traveling alone on an irreversible journey into the intergalactic void. Tracking these runaway stars is more than just tracing an escape. It is a form of celestial forensics. Each hypervelocity star carries a frozen record of its violent birth. By meticulously plotting its path backward across millions of light years, astronomers can triangulate the precise location and even infer the mass of the black hole that ejected it. They become living probes, tracing the invisible contours of the galaxy's deepest gravitational well. Their trajectories paint a map of the central powerhouse's influence, offering clues about its past activity, even during its current quiet phase. Every runaway star is a message in a bottle, flung from the galactic core, telling the story of a moment of extreme violence that forever altered its destiny. These stellar escapees are not the only traces of ancient violence written across the galaxy. Phenomenon number 6 reveals itself not in visible light, but in whispers from the radio spectrum, the inexplicable radio loops. When astronomers point radio telescopes toward NGC 1300, they detect something astonishing. Enormous, faint arches of radio emission rise high above and below the flat plane of the spiral disk, like the ghostly outlines of colossal bubbles. These are not the small, tangled remnants of recent supernova. They are structures on a galactic scale, spanning tens of thousands of light years, and their origin is a profound mystery. They are the fossilized energy of events so powerful they once shook the entire galaxy. One compelling theory points an accusing finger back at the galaxy's quiet heart. While the central black hole is dormant now, these loops could be the lingering echo of a time when it was anything but. Billions of years ago, the supermassive black hole may have awakened in a cataclysmic feeding frenzy. As it devoured matter, it would have belched out twin jets of superheated particles and radiation at nearly the speed of light, punching directly up and down through the galactic disk. These jets would have inflated vast cavities in the surrounding gas, creating the giant radio bubbles we see as faint loops today. The black hole's roar is silent, but its ancient shout is still etched into the fabric of space around it. Alternatively, the source of these colossal structures might not be the central monster, but a galaxy-wide fever of creation. The loops could be relics of a sustained starburst era, a period billions of years ago when star formation erupted across NGC 1300 at a ferocious, unsustainable rate. In such a frenzy, thousands of massive stars would have been born only to die quickly in supernova explosions. The combined shockwaves from these countless stellar deaths would have merged into a single, overwhelming galactic wind, blowing a gigantic bubble of hot gas out from the disk and creating these radio-emitting shells. Studying these loops is an act of cosmic archaeology. They are sedimentary layers in the galaxy's history book. By measuring their size, shape, and energy, astronomers can attempt to date the cataclysm that formed them, calculating whether the galaxy's most violent episode was a sudden eruption from its core or a prolonged fever of stellar birth and death. These faint radio whispers force us to listen to the deep past, to a time when NGC 1300 was a very different and far more violent place. The colossal energy required to forge those radio loops hints at the true, hidden weight of NGC 1300. Phenomenon number 7 is a gravitational lens candidate, a cosmic illusion that could reveal the galaxy's total mass in one breathtaking observation. There is a tantalizing possibility that the immense combined gravity of all the stars, gas, and unseen dark matter in this spiral is acting like a giant natural telescope. If a much more distant galaxy lies in a perfect line directly behind NGC 1300 from our viewpoint, a profound effect should occur. The foreground galaxy's gravity will warp the very fabric of space around it, bending the light from the background galaxy as it travels toward us. This is not a trick of mirrors, but a fundamental prediction of Einstein's theory of relativity, where mass distorts spacetime itself. To understand this, picture a perfectly flat, taut bedsheet representing empty space. Now place a heavy bowling ball in the center, representing the galaxy. The sheet dips and curves around the weight, If you roll a marble across that curved sheet, its path will bend. Light from the distant galaxy is like that marble. Its straight path is curved by the depression created by NGC 1300's mass. From our perspective, this warping creates strange, beautiful distortions. Instead of seeing the background galaxy as a single, sharp point, its light is smeared into a faint arc, or even a complete circle of light encircling the foreground galaxy, an effect known as an Einstein ring. It is a cosmic mirage, where one galaxy appears as multiple stretched images around another. The hunt for this ghostly ring or arc within the observational data of NGC 1300 is a meticulous process. Astronomers comb through deep field images, looking for any faint, unnatural curvatures of light that cannot be explained by the spiral's own stars. They search for symmetrical smudges or duplicate features that should not exist. Finding even a partial lens would be a monumental discovery. Why? Because the precise shape and size of the distorted image acts as a direct cosmic scale. The degree of bending is dictated solely by the total mass of the foreground galaxy that is causing the warp. By measuring the distortion, scientists could calculate the exact gravitational pull of NGC 1300, providing the most direct measurement possible of everything it contains. This includes all the dark matter that we cannot see, offering a final answer to how much of that invisible scaffold truly holds the galaxy together. This potential lens is more than an illusion. It is a key. If confirmed, it would unlock the true weight of the galaxy, allowing us to peer not just at its light, but to literally weigh its shadow. The true weight of a galaxy should cast a visible shadow in the form of smaller companions. Phenomenon number 8 is the missing satellite galaxy problem, a deep cosmological puzzle that NGC 1300 throws into sharp relief. According to our most sophisticated computer simulations of the universe, a grand spiral like this should be the center of a bustling celestial metropolis. Its immense gravitational pull, shaped by both visible stars and its vast dark matter halo, should have captured dozens, if not hundreds, of smaller dwarf galaxies over billions of years. These satellite galaxies should now orbit it like moths around a brilliant flame, a visible testament to its dominance. Yet when astronomers count, the numbers do not add up. Observations reveal only a sparse handful of such companions around NGC 1300, a quiet neighborhood where a cosmic crowd was predicted. So where did all the satellites go? One stark possibility is that the history of this spiral is written in acts of galactic cannibalism. The missing dwarfs may not be missing at all. They may have been consumed. Over the eons, NGC 1300's gravity could have slowly torn apart these smaller galaxies, stretching them into the long, faint streams of stars we now see as phantom arms. Their stars were digested, becoming part of the larger spiral's body, leaving only these ghostly digestive trails as evidence of the feast. The galaxy's majestic spiral structure itself might be built, in part, from the remains of its former companions. Another, more mysterious theory suggests the satellites are there, but hiding in plain sight. They could be composed almost entirely of dark matter, with so few stars that they emit virtually no light for our telescopes to catch. These would be invisible ghosts held in orbit by gravity alone, massive yet dark, solving the numerical puzzle while deepening the mystery of what galaxies are truly made of. This missing satellite problem is not unique to NGC 1300. It is a universal discrepancy that challenges our core understanding of dark matter and cosmic evolution. If the simulations are correct, then our theories about how dark matter clumps together in the early universe may be flawed. If the observations are complete, then we must explain why galaxy formation is so efficient at destroying or hiding its smallest building blocks. NGC 1300's quiet celestial neighborhood is not a sign of isolation, but a clue. Its lack of visible satellites points to a violent past of assimilation, or to a present filled with invisible, shadowy companions we are only beginning to learn how to see. This invisible scaffolding of dark matter and missing satellites has left behind a tangible clue in the form of faint, drifting gas. Phenomenon number 9 is the asymmetric hydrogen cloud, a vast and lopsided shroud of raw material that tells a story of unfinished construction. Observations in radio waves reveal an enormous reservoir of neutral hydrogen gas, known as HI, that stretches far beyond the bright disk of stars we see in photographs. This is not a neat, symmetrical halo. It is a lopsided, messy structure that does not rotate in sync with the majestic spiral below. It hangs over the galaxy like a tattered, cosmic cloak, drifting to its own slow rhythm. This cloud is the galaxy's hidden reservoir, and its very asymmetry is a glaring clue that NGC 1300 is still gathering its building blocks from the space around it. So where did this lopsided shroud come from? One compelling origin story is one of cosmic inheritance. This could be primordial gas, the original raw hydrogen and helium from the birth of the universe itself, that never fully collapsed to form the galaxy's first stars. For billions of years, it has lingered in a diffuse halo, a leftover from the construction process that is only now, slowly and unevenly, beginning to rain down onto the galactic disk under its own weak gravity. This would be a galaxy still feeding on the crumbs of its own creation, a process of growth that is achingly slow and inherently messy, explaining the cloud's irregular shape. But there is a more dramatic possibility. The cloud might not be inherited gas at all, but captured debris. It could be the mangled remains of a small, gas-rich dwarf galaxy that ventured too close. NGC 1300's gravity would have stretched the intruder into a long, streaming arc of gas, tearing it apart in a process called tidal disruption. The stars of that dwarf galaxy may have been stripped away and assimilated long ago, but this immense cloud of hydrogen is the last, dissipating breath of that ancient collision, still settling into a chaotic orbit. The cloud's refusal to rotate neatly is the key evidence here. If it were a natural part of the galaxy, it should follow the overall spin. Its lopsided drift suggests it is new to the neighborhood, a recent arrival still being pulled into the galactic gravitational dance. Studying this asymmetric cloud is like watching a galaxy eat in slow motion. It provides a direct snapshot of how galaxies grow not just by crashing into stars, but by slowly, messily accreting the cold gas needed to forge new generations of suns. This faint radio whisper is a living record, a sign that even a galaxy that looks complete and majestic is still under construction, its final shape being written by the invisible rain of ancient matter from the void. The galaxy's hidden gas clouds are not the only reservoirs of raw power. Phenomenon number 10 is a cosmic beacon of pure violence, an ultra-luminous X-ray source, or ULX. This is not the quiet supermassive black hole at the galactic core. This object is a searing pinpoint of energy located far out in one of the spiral arms, shining with the X-ray brightness of millions of suns, all concentrated into a single, furious point. Its location is the first major clue to its identity. Such extreme energy, equivalent to a small galaxy's worth of output, is usually only seen at the hearts of galaxies where supermassive black holes reside. To find it in the galactic suburbs is like discovering a single house on a quiet street that is producing the power output of an entire city. So what could possibly generate such ferocious radiation so far from the center? Astronomers are faced with two equally fascinating possibilities. The first is an intermediate mass black hole, a long-sought cosmic missing link. We know of relatively small black holes formed from collapsing stars, and we know of the supermassive monsters at galactic centers. An intermediate mass black hole would bridge that gap, weighing perhaps thousands of times the mass of our Sun. Such an object, if it wandered into a dense cloud of gas or began tearing apart a companion star, could feed at a tremendous rate, creating the incredible X-ray glow we see. Its presence in the spiral arm suggests it could be the remnant core of a dwarf galaxy that was consumed long ago. A surviving monster from a past merger now lurking in the outskirts. The second possibility is just as strange. This ULX might be a normal stellar black hole, one born from the death of a single massive star, but feeding in a way that defies all expectations. Imagine a black hole only 10 or 20 times the Sun's mass, but with a voracious appetite. If it were in an extremely tight orbit with a massive companion star, it could strip material away at a phenomenal rate. The stolen gas doesn't fall in quietly. It forms a searing, whirling disk of superheated plasma around the black hole, glowing with intense friction and emitting those torrents of X-rays before finally crossing the point of no return. This scenario pushes the known physics of accretion to its absolute limits. A feeding frenzy so extreme it challenges our models of how stellar black holes behave. The existence of this ULX, regardless of its true nature, forces a profound realization about galactic life cycles. It tells us that the most energetic events are not confined to the galactic downtown. The spiral arms, those stellar nurseries where stars are born, are also places where the most massive stars meet spectacular, violent ends. A ULX is likely the final chapter of a star much larger than our Sun, a chapter that leads not to quiet darkness, but to a legacy of terrifying brilliance. This distant X-ray scream is a reminder that cataclysm can happen anywhere, turning a quiet corner of a spiral arm into the site of a cosmic power plant that briefly outshines everything around it. The same spiral arms that host these violent X-ray beacons also hold ancient relics of a different kind of cataclysm. Phenomenon 11 is a chemically peculiar globular cluster, a dense, spherical swarm of hundreds of thousands of ancient stars orbiting NGC 1300. These clusters are typically the fossils of the universe's youth, composed of stars that formed from pristine, simple gas. But this particular cluster is a glaring exception. Detailed analysis of its starlight reveals a bizarre chemical signature, with stars showing strangely high abundances of heavy elements like europium and even traces of gold. This is not a subtle difference, it is a fundamental anomaly. In the cosmic kitchen, these elements are not cooked up in ordinary stars. They require a recipe of unimaginable violence and rarity. The presence of these metals in such an ancient object is a smoking gun. It tells us that the cloud of gas from which this entire cluster condensed billions of years ago was already seeded with these exotic materials. So what event could have poisoned that primordial gas so early in cosmic history? The leading suspects are the most extreme explosions the universe can produce. One possibility is a specific, rare type of supernova from the first generation of truly massive stars. These behemoths, perhaps hundreds of times the mass of our Sun, would have lived fast and died young in titanic explosions that forged heavy elements in their cores and scattered them into space. Alternatively, and perhaps more likely, is the signature of a neutron-star merger. Picture the final, spiraling dance of two ultradense stellar corpses. When they finally collide, they do not just explode, they create a kilonova, a forge of cosmic alchemy so powerful it can produce staggering amounts of gold, platinum, and rare earth elements like europium in a single, blinding flash. This peculiar cluster, then, is a time capsule. It captured the fallout from one of these incredibly rare events that occurred even before the cluster itself was born. The cloud that would become the cluster drifted through that enriched debris, mixing it in, and then collapsed to form its stars, locking that exotic chemistry into every sun. This means we are not just looking at a group of old stars. We are looking at the preserved aftermath of a single, catastrophic moment from the dawn of time, a moment that literally sprinkled gold into the cradle of this star cluster. It forces us to rewrite the early history of NGC 1300, suggesting its building blocks were not just simple hydrogen, but were already complex and enriched by the universe's first and most spectacular acts of creation. That ancient gold-forging violence is not the only force that writes itself into the final moments of stars. Phenomenon 12 presents a cosmic alignment of death, the aligned planetary nebulae. Scattered across the disk of NGC 1300 are the beautiful, ghostly shells of dying sun-like stars, known as planetary nebulae. Each one is a stellar farewell note, a glowing cloud of gas ejected from an aging star in its final 1,000 years. These nebulae often form spectacular bipolar shapes, with two opposing jets or lobes that make them look like glowing hourglasses or butterflies in space. Conventional wisdom tells us these shapes should point in random directions, a chaotic gallery of stellar last breaths determined by the individual star's rotation and local conditions. But here, astronomers have noticed something deeply unsettling. The bipolar outflows from multiple planetary nebulae are not pointing every which way. Their axes of symmetry, the imaginary lines running through their two lobes, appear to be aligned with each other, and more strikingly, with the overall rotational axis of the galaxy itself. It is as if a silent command has been issued across thousands of light years, telling these dying stars which way to exhale their last. This is not a random pattern, it is a coordinated one, and it points to an invisible director shaping the final act of stellar life. The leading suspect for this cosmic choreography is a force we cannot see directly, but can infer from its immense power, the galaxy's magnetic field. Picture the entire spiral disk of NGC 1300 not just as a collection of stars and gas, but as a vast, dynamic electrical generator. As the galaxy rotates, its charged particles and ionized gas move through space, generating a magnetic field that can weave through the entire structure like an invisible grid of lines. These magnetic fields, while weak by human standards, are coherent over staggering distances. When a sun-like star reaches the end of its life and begins to shed its outer layers, that ejected material is not neutral. It is a plasma, a soup of charged particles, and charged particles are slaves to magnetic fields. The theory suggests that as the star's dying gasp expands into the surrounding interstellar medium, the galaxy's large-scale magnetic field acts like a cosmic mold. It guides and shapes the outflowing plasma, channeling it along the preferred magnetic field lines, which themselves are oriented along the galaxy's spin axis. The star's final geometry is no longer a matter of its own private history, but is imprinted upon it by the galactic environment. It is a profound connection between the smallest and largest scales. The quiet, billion-year life of a single, modest star ends with its form being dictated by the galaxy it called home. This alignment is more than a curiosity. It is a fossilized magnetic field map. By studying the orientation of these glowing hourglasses, astronomers can indirectly trace the structure and strength of NGC 1300's invisible magnetic skeleton, revealing how forces that govern the entire spiral can reach down to orchestrate the death of one of its most common citizens. The invisible magnetic fields that guide dying stars are just one expression of a deeper, unseen architecture. Phenomenon 13 takes us to the very foundation of that architecture, the dark matter halo profile. Everything we have observed so far, from the stable bar to the missing satellites, points to NGC 1300 being embedded within a vast, spherical cloud of dark matter. This invisible halo provides the extra gravitational glue that holds the entire structure together. But its true nature is not uniform, and recent data has revealed a startling detail about its very heart. By meticulously mapping the rotation speeds of stars and gas at different distances from the galactic center, astronomers can weigh the invisible mass pulling on them. The results point to a halo with a chord profile. This means that the density of dark matter in the innermost region of the galaxy is relatively constant, like the dense but uniform pit of a peach. This stands in stark contrast to the long-standing prediction from cosmological simulations, which favored a cuspy profile. A cuspy halo would have dark matter density rising sharply and endlessly toward the center, creating a steep, needle-like spike of invisible matter, more like the pointed tip of a thorn. The fact that NGC 1300 and many galaxies like it seem to have a soft core instead of a sharp cusp is a major puzzle with enormous implications. Why does this tiny detail about the halo's inner shape matter so much? It strikes at the heart of what dark matter actually is. The cuspy profile is the expected outcome if dark matter is made of cold particles that barely interact with each other or with normal matter, just passing through each other like silent ghosts. Their gravity alone would pull them into that dense, sharp peak at the center. A soft, constant density core, however, suggests something prevented that peak from forming. One radical possibility is that dark matter particles can, in fact, interact with each other through some force other than gravity. If dark matter particles can bump off one another, they would behave more like a diffuse gas, smoothing out the central cusp into a gentle core through countless tiny collisions over billions of years. This would mean dark matter is not entirely dark to itself, opening a window into a whole new physics operating in the shadows. The other leading explanation looks not to the nature of dark matter, but to the violent history of the galaxy itself. Remember those colossal radio loops and the potential for past black hole outbursts? That energy had to go somewhere. Intense, repeated bursts of energy from the galactic core, whether from a feeding supermassive black hole or a rampant starburst era, could have acted like a cosmic mixing spoon. The explosive waves would have physically pushed and churned both the normal gas and the dark matter, gravitationally sloshing it around and smoothing out any nascent cusp into a broader core. In this scenario, the dark matter halo's profile becomes a fossil record of the galaxy's most energetic chapters, so the soft core presents a fundamental choice. Is it a sign that dark matter has a rich, complex physics of its own, capable of self-interaction? Or is it simply a scar, a testament to how the furious astrophysical events within a galaxy can reshape, even the invisible scaffolding that holds it up? The answer, hidden in the gentle curve of NGC 1300's rotation, could rewrite the rules for the most abundant yet most mysterious substance in the cosmos. The gentle core of the dark matter halo may itself be a testament to ancient acts of galactic violence. Phenomenon 14 is a direct witness to that violence, a faint, arcing river of stars winding around NGC 1300 like a celestial scar. This is a tidal stream, the ghostly remains of a smaller galaxy that ventured too close and was torn apart over billions of years. It is the most direct evidence we have of galactic cannibalism in this spiral's past. To understand how such a beautiful, delicate structure forms from utter destruction, we turn to the simulations. They show a dance of gravitational forces that is both slow and brutal. When a dwarf galaxy, perhaps 1/100th the mass of NGC 1300, drifts into its gravitational reach, the larger spiral does not swallow it whole. Instead, it begins a process of tidal stretching. The force of gravity on the side of the dwarf facing the giant is stronger than the force on its far side. This difference, the tidal force, starts to pull the victim apart. Over countless orbits, the dwarf galaxy is stretched into a long, looping streamer of stars, like cosmic taffy, that gradually disperses along its orbital path around the predator. The stars are not destroyed. They are simply separated from their original family and strung out into this faint, mournful arc. Analyzing this specific stream in NGC 1300 is an act of cosmic archaeology. By mapping its exact curvature and the density of stars along its length, astronomers can run the clock backward. They can calculate the original orbit of the doomed dwarf galaxy, estimate its mass before it was dismembered, and even determine roughly when this act of consumption began. The stream acts as a fossilized orbit, preserving the dynamics of a cataclysm that unfolded over eons. But the clues go deeper than just motion. The chemical fingerprints of the stars within the stream tell their own story. If they show a distinct, uniform signature different from the stars in NGC 1300's main disk, it confirms they are all orphans from the same foreign system. This allows scientists to reconstruct the victim's properties. Was it a gas-rich dwarf that sparked a wave of new star formation as it was consumed, or a gas-poor, ancient collection of stars that added only old metal to the spiral's halo? This faint river of light is more than a relic. It is a living chapter. It demonstrates that majestic spirals like NGC 1300 are not born in isolation. They are built through a history of mergers and acquisitions. Every star in that stream is a survivor, a refugee from a galaxy that no longer exists, now forever bound to the spiral that consumed its home. Their quiet, arcing path is a permanent monument to the fact that the beauty of a galaxy is often forged by forces of immense and patient destruction. That faint river of cannibalized stars points to a history written in dust as much as light. Phenomenon 15 is a mysterious infrared glow, a pervasive heat signature that blankets NGC 1300 in a warmth that shouldn't exist. When astronomers look beyond visible light, into the infrared part of the spectrum, they measure an excess of energy, a diffuse and persistent glow that outshines what all the known stars and warm dust clouds can possibly produce. It is as if the entire galaxy is wrapped in a faint cosmic heating blanket, radiating a gentle warmth whose source remains hidden. This is not the intense blaze of star formation, but something softer, more enigmatic, and woven throughout the spiral structure. So what could be generating this pervasive infrared excess? The most grounded explanation points to a population of dust we simply cannot see directly. This could be an immense reservoir of exceptionally cold interstellar dust, perhaps only a few degrees above absolute zero. Such frigid grains, spread thinly across vast regions between the stars, would be invisible in optical light, but would glow faintly in the far infrared. Think of it as the galaxy's background thermal radiation, the leftover warmth from countless ancient stellar winds and supernova that has been absorbed and re-radiated by this diffuse, icy haze. Another compelling candidate involves not just dust, but complex chemistry. The glow could be the collective signature of vast clouds of complex organic molecules known as polycyclic aromatic hydrocarbons, or PA. These are essentially soot, intricate carbon-based compounds that form in the outflow from dying stars. When struck by ultraviolet light from young, hot stars, these molecules don't just get hot, they vibrate in specific ways, emitting a distinctive infrared fluorescence. A galaxy-wide mist of this cosmic soot could be responsible for the unexplained glow, a faint shimmer from the basic building blocks of life scattered across the void. Yet, within the realm of space mystery, there exists a more speculative, thrilling possibility. This excess infrared radiation fits a very specific profile. It is the kind of waste heat one might expect from a hypothetical Kardashev Type II civilization, a society so advanced it captures the total energy output of its star. The theoretical signature of such an unimaginable feat of engineering would not be a directed signal, but a byproduct, an unavoidable thermodynamic consequence. The glow of spent energy radiating away as low-grade infrared heat. While astronomers overwhelmingly attribute the glow to natural causes like cold dust or complex molecules, the mere fact that the data allows for this remote, breathtaking speculation is part of what makes NGC 1300 so compelling. It reminds us that when we observe a galaxy, we are not just cataloging stars and gas, we are measuring its total energy budget, and sometimes the ledger contains an entry we cannot yet fully explain. That unexplained warmth, whether from icy dust, cosmic soot, or something else entirely, is a quiet reminder that even a galaxy's heat holds a story we are still learning to read. This pervasive warmth is not the only sign of a galaxy still gathering its materials from the void. Phenomenon 16 reveals a dynamic and violent contradiction at the very heart of NGC 1300, the counter-rotating gas disk. Deep within the inner regions of the galaxy, astronomers have mapped a portion of the interstellar gas that is doing the unthinkable. While the vast majority of the galaxy's stars and gas spin together in one majestic, coordinated direction, this specific reservoir of gas is spinning backwards. It is a cosmic traffic collision happening in extreme slow motion, a clear and recent scar from an act of galactic theft. This is not a feature that arises naturally from a galaxy's birth. A disk of gas spinning in perfect opposition to the main galactic rotation is a glaring signature of an external event. The most logical explanation is a recent merger or accretion event where NGC 1300 captured a significant cloud of gas from its surroundings. Picture a small, gas-rich satellite galaxy or even a massive intergalactic hydrogen cloud on a retrograde orbit, meaning it was swinging around the galaxy in the opposite direction to everything else. As it was torn apart by tidal forces, its gas was not immediately assimilated. Instead, it retained its original backwards momentum, settling into a separate, counter-rotating disk within the inner galaxy. This setup creates a zone of immense and continuous violence, where the forward-spinning main disk and the backward-spinning gas disk meet. They do not simply pass through each other. Their opposing motions create colossal, standing shock fronts, like permanent sonic booms on a galactic scale. In these turbulent interfaces, clouds of gas moving in opposite directions slam together at phenomenal speeds. The result is not chaos for chaos's sake. It is a powerful natural compressor. This violent collision squeezes the gas clouds with extraordinary force, dramatically increasing their density. And in the cosmos, density is the trigger for creation. When a gas cloud becomes dense enough, gravity takes over, pulling it inward until it collapses and ignites into new stars. Therefore, these shock fronts become unnatural, hyper-efficient stellar assembly lines. They can trigger intense, localized bursts of star formation, creating sparkling clusters of young, hot stars right along these invisible lines of collision. This counter-rotation is more than a curiosity. It is a direct observation of a galaxy caught in the act of digesting a recent meal. The backwards spinning gas is the fresh, undigested material, and the shock-induced star formation is the metabolic heat from that digestion. It provides a rare, real-time look at how galaxies grow and change, not just through the slow rain of gas, but through violent, directional acquisitions that literally turn the inner workings of the galaxy against itself to forge new light from the conflict. The violent stellar nurseries forged by colliding gas are built upon a foundation of cosmic measurement, a foundation that NGC 1300 now threatens to shake. Phenomenon 17 presents the anomalous Cepheid variables, stars that have long been the trusted mile markers of the universe, yet here they are behaving in ways that defy the textbooks. Cepheid variables are pulsating giants, stars that rhythmically brighten and dim over periods of days or weeks. Their true power lies in a beautifully simple relationship discovered over a century ago. The longer a Cepheid's pulsation period, the higher its true intrinsic brightness. This period luminosity law is the golden rule of cosmic cartography. By measuring how long a Cepheid takes to pulse and comparing its true brightness to how dim it appears from Earth, astronomers can calculate its distance with remarkable precision. These stars are the first crucial rung on the cosmic distance ladder, the tool we use to measure the scale of our local universe and beyond. But within NGC 1300, a number of these celestial yardsticks are giving inconsistent readings. Their pulsations are irregular, or their brightness does not match the expected pattern for their period. It is as if several perfectly crafted rulers in a single workshop were found to have centimeters of different lengths. So what could be corrupting these reliable cosmic beacons? One compelling answer lies in companionship. An anomalous Cepheid might not be a single, pulsating giant, but one half of a tight binary star system. If the Cepheid has a companion star, their light blends together in our telescopes. The companion's steady glow contaminates the measurement of the Cepheid's rhythmic brightening and dimming, making its pulsations appear off rhythm and its average brightness seem wrong. We are trying to measure the heartbeat of one star, but hearing two hearts beating out of sync. Another possibility is that we are not looking at standard Cepheids at all, but at a rarer, more exotic class. Some could be overtone pulsators, stars that vibrate in a different harmonic, like a guitar string producing a different note from the one expected. Others might be transitioning between evolutionary stages, their internal structures in temporary turmoil that disrupts the clean relationship between pulse and power. The implications of these anomalies ripple far beyond this single galaxy. If the Cepheids in NGC 1300 are unreliable, then the distance we have measured to this iconic spiral could be wrong. And because this galaxy is used as a stepping stone to calibrate distances to even farther objects, a small error here magnifies across the cosmos. This directly impacts our measurement of the Hubble constant, the number that describes how fast the universe is expanding. Different methods for calculating this constant already disagree, creating a major crisis in cosmology known as the Hubble tension. Anomalous cepheids in a key galaxy like NGC 1300 could be a clue, revealing a hidden flaw in one of our most fundamental measurement tools. Perhaps some cepheids are not the simple standard candles we believed, but more complex objects whose environments or life stories alter their glow. Each erratic pulse from these stars is a question mark written in starlight, forcing us to re-examine the very rulers we use to map the expanding universe, reminding us that even our most trusted guides can hold secrets. Those erratic cosmic mile markers point toward a hidden energy that once blasted from the galactic core. Phenomenon 18 is a ghostly echo of that power, a potential gamma-ray bubble analog. In our own Milky Way, astronomers have discovered colossal structures known as the Fermi bubbles, towering lobes of high-energy gamma-ray emission that balloon tens of thousands of light-years above and below the galactic plane. These are not made of stars or gas, but of ultra-fast particles moving at nearly the speed of light, trapped within a magnetic cage. They are the lingering signature of a past cataclysm, a testament to a time when our galaxy's central black hole roared to life. Now, scientists are searching for a similar, fainter signature around NGC 1300. If detected, these would be smaller, ancient versions of the same phenomenon, gigantic invisible balloons of pure energy inflating from the spiral's heart. To understand what created them, we must revisit the dormant monster at the galaxy's center. While it sleeps today, these hypothetical bubbles would be the definitive proof of a previous awakening. Billions of years ago, during a frenzied feeding episode, the supermassive black hole would have done more than just consume matter. As materials swirled into its abyss, powerful magnetic fields near the event horizon could have funneled some of the inflowing gas into two opposing narrow jets. These jets, composed of charged particles accelerated to almost light speed, would have shot out perpendicular to the galactic disk like cosmic blowtorches. For millions of years, they would have plowed into the halo of thin gas surrounding the galaxy, inflating vast, bubble-like cavities and filling them with this seething particle soup. The jets eventually shut off, leaving behind these expanding shells of high-energy particles that slowly cool and fade over eons. Finding these structures in NGC 1300 would be a direct look into its energetic biography. The size of the bubbles would tell us how long the black hole's outburst lasted and how much energy it unleashed. Their symmetry, whether perfectly aligned or slightly tilted, could reveal the spin axis of the black hole itself at that moment in cosmic history. And their faint, diffuse glow in gamma rays would connect directly to the giant radial loops we discussed earlier, suggesting both are different signatures of the same ancient explosive event. These invisible bubbles are more than just fossils. They are a form of galactic weather. They show how a single violent event at the core can reshape the entire galactic atmosphere, blowing a permanent hole in the surrounding medium and creating a legacy of radiation that lasts for billions of years. The hunt for these gamma-ray ghosts is a search for the final, fading breath of a fury that once defined this beautiful spiral. The galaxy's violent weather can forge islands of light in the most unexpected places. Phenomenon 19 is an isolated superstar cluster, a city of suns adrift in the cosmic suburbs. Far from the bustling spiral arms and their glowing nebulous nurseries, This object hangs in a quiet, seemingly empty region of the galactic disk. Yet it is not a quiet object at all. It is a monstrous, glittering ball containing hundreds of thousands of young, massive stars, all packed together with a density that defies the peaceful emptiness around it. It shines with the ferocious blue-white glare of stellar youth, a brilliant anomaly in the galactic hinterlands. How could such an immense and dense family of stars be born in a place with no visible raw materials? The formation of a superstar cluster typically requires a colossal, collapsing cloud of gas and dust, the kind only found in the densest spiral arms. For one to appear in isolation is like finding a metropolis thriving in the middle of an open desert, with no roads leading to it. One theory suggests this is not a native-born city, but a captured one. This brilliant cluster may be the remnant core of a small dwarf galaxy that was consumed by NGC 1300 in the distant past. As the larger spiral's gravity stretched and shredded the dwarf galaxy, most of its stars were pulled away into those faint tidal streams we discussed earlier. But its dense central star cluster, bound tightly by its own gravity, could have survived the ordeal intact. It now orbits the galaxy as a celestial orphan, a glittering trophy from an ancient act of conquest, its youthful appearance preserved because its stars were all born in a single, frantic burst before the capture ever happened. The other explanation is even more dramatic, and it requires rethinking how star formation can be triggered. Imagine two enormous, dark molecular clouds, each containing the mass of millions of suns, drifting through this quiet region of the galactic disk. By chance, they are on a collision course. When they finally slam together, the impact is not a gentle merging. It is a violent, chaotic compression event that sends shockwaves rippling through the combined gas. This sudden, extreme squeeze triggers a chain reaction of collapse, igniting a firestorm of star formation so intense and efficient that it uses up almost all the available gas in one go, forging this single, spectacular cluster. Once the brilliant stars ignite, their fierce radiation and stellar winds would blow away any remaining dusty cocoon, leaving the cluster exposed and isolated, with no trace of its violent birth cloud. This isolated supercluster is a testament to the fact that creation in a galaxy is not confined to designated zones. Cataclysm, whether from a galactic merger or a chance cloud collision, can ignite stellar fireworks anywhere, leaving behind a permanent, brilliant monument to a moment of extreme and localized chaos. It stands alone, a silent, blazing question mark, forcing us to wonder what other islands of unexpected light might be hiding in the quiet spaces between the spiral arms. A brilliant, isolated cluster of stars is not the only kind of signal that could emerge from the galactic quiet. Phenomenon 20 presents a hypothetical scenario that would send shockwaves through the world of astronomy. A repeating fast radio burst source anchored within NGC 1300. Fast radio bursts, or FRB, are among the most electrifying mysteries in modern cosmology. They are bursts of intense radio waves that last for mere milliseconds, yet in that flash, they can release more energy than our sun does in 80 years. Most are one-off events, cosmic lightning strikes detected from billions of light-years away, their origins lost in the deep field of space. But a precious few are repeaters, firing off multiple bursts from the same patch of sky. Now, imagine the frenzy if one of these repeating FRBs was definitively traced not to a distant, anonymous blob, but to a specific location within the majestic, well-studied spiral of NGC 1300. The entire field would be turned on its head. Suddenly, astronomers would have a target. They could point every available telescope, from radio arrays to X-ray observatories, at a known galactic environment. They could search for a visible counterpart, a specific star cluster, a nebula, or a remnant that might be the engine behind these colossal, repeating radio screams. The mystery of what creates FRBs is still wide open. The leading suspects are already inhabitants of galaxies like NGC 1300. One prime candidate is a magnetar, an ultramagnetic neutron star, the collapsed core of a massive star that possesses a magnetic field a quadrillion times stronger than Earth's. Think of it as a cosmic powerhouse wound so tight it occasionally snaps, its crust cracking under magnetic strain and releasing a torrent of radio energy in a catastrophic starquake. Another possibility is the aftermath of a violent merger, like the collision of two neutron stars or a neutron star with a black hole. Such an event could produce a single titanic burst as the final wreckage collapses. But a repeater suggests a source that survives its own outburst, pointing strongly to a persistent object like a magnetar in a particularly active and unstable state. To have such an object in NGC 1300 would be a gift beyond measure. It would allow scientists to study the local environment of an FRB source in unprecedented detail. Is it nestled in a young, chaotic stellar nursery, or is it drifting through an old, quiet region? What is the density of gas and magnetic fields around it? The answers would provide the crucial context needed to finally solve the puzzle. This single, repeating signal would transform the galaxy from a subject of study into a living laboratory for the most extreme physics in the universe, a place where the cosmos periodically shouts its secrets in a language of pure, concentrated energy. The galaxy's outermost frontier holds a secret in its very shape. Phenomenon 21 is the warped outer disk, a subtle but definitive bend in the very fabric of NGC 1300. Far from the brilliant central bar and spiral arms, the thin plane of stars that makes up the galactic disk does not remain perfectly flat. Instead, it twists and curves gently upward on one side and downward on the other, like a colossal vinyl record left too long in the sun. This is not a flaw in the image, but a real, physical distortion of the galaxy's outermost reaches, a sign that its peaceful rotation has been recently disturbed. A warp like this is the galaxy's equivalent of a wobbly spinning top, and in the cosmos, such wobbles almost always come from a gravitational nudge. The most likely culprit is a recent, close gravitational encounter. While not a direct collision, a near miss with a sizable neighboring galaxy, or even a massive but invisible cloud of dark matter, could have provided the necessary tug. Picture the smooth, flat plane of the disk as a calm pond. If you toss a large rock nearby, the resulting ripples will not just spread out, they will slosh the water at the edges, creating a temporary, uneven lip. A passing galaxy acts as that rock, its gravity creating a tidal force that pulls on the outer disk, where the galaxy's own gravitational hold is weakest, leaving it permanently bent. Astronomers scan the cosmic neighborhood for suspects. Is there a galaxy close enough, on a trajectory that could have caused this warp within the last few 100 million years? Identifying a candidate would turn the warp from a mystery into a time-stamped event, a clue to a specific chapter in the galaxy's recent history. However, the culprit may no longer be visible. The warp could be a lingering effect from an ancient encounter, a fossilized distortion from a galaxy that passed by billions of years ago and has since moved far away. The outer disk, once bent, can retain that shape for an astonishingly long time, oscillating slowly like a vast, slow-motion wave frozen in starlight. This persistent warp forces a deeper question about what truly surrounds NGC 1300. If no visible galaxy is to blame, could the distorting force have been an entirely dark matter subhalo, a massive but completely invisible clump of the universe's most mysterious substance passing silently through the galactic outskirts? The bent disk is therefore a delicate probe. By measuring its exact shape and degree of twisting, scientists can weigh the object that caused it, whether seen or unseen. It is a permanent record of a gravitational handshake, a signature written in the displaced orbits of billions of stars, telling us that even in its quiet outer realms, this galaxy bears the marks of the dynamic and crowded universe it calls home. A galaxy's history is written in the ages of its stars, a layered timeline of stellar generations. Phenomenon 22 uncovers a strange silence in that timeline, the missing intermediate age stars. When astronomers conduct a cosmic census of NGC 1300, categorizing its suns by their color, brightness, and chemical makeup to determine their ages, they find a puzzling demographic gap. The galaxy has a rich population of ancient stars, over 10 billion years old, and a vibrant population of young stars, born in the last few 100 million years. But the middle chapter is strangely thin. There is a relative scarcity of stars in the prime of galactic life, those roughly 3 to 5 billion years old. This is not a minor statistical blip. It is a glaring absence that suggests a profound and prolonged quiet period in the galaxy's story, a billion-year lull where the music of creation nearly stopped. What cosmic event could have silenced a spiral galaxy's star-forming engine for so long? One leading suspect is an early, violent outburst from the galactic core, an active galactic nucleus, or AN. Remember those colossal radio loops and potential gamma-ray bubbles. They hint at a past when the central black hole was awake and furious. In this scenario, billions of years ago, that monster may have entered a cataclysmic feeding phase. As it devoured matter, it would have blasted the surrounding galaxy with unimaginable levels of radiation and powerful jets. This energy would have acted like a cosmic blowtorch, violently heating the galaxy's vast reservoirs of cold hydrogen gas. Star formation requires cool, dense clouds to collapse under their own gravity. If the Asian outburst heated all the gas to a thin, hot plasma, it would have effectively sterilized the galaxy, putting star formation on hold for eons until that superheated gas could slowly, gradually radiate away its energy and cool back down. The galaxy was essentially put into a forced hibernation by its own central engine. Another possibility looks outward, to the galaxy's environment. Perhaps NGC 1300 experienced a form of cosmic starvation. Spiral galaxies are not closed systems. They can accrete fresh, cold gas from the vast filaments of the cosmic web, the raw fuel for new stars. If the galaxy moved through a particularly hot, dense region of intergalactic space, or if its trajectory took it away from these nurturing filaments for a long period, that external fuel supply could have been cut off. The galaxy would have used up its available cold gas in an initial burst of star formation, and then, with no way to replenish its tanks, starved. The existing stars would age, but few new ones would be born to fill the intermediate age bracket, creating this silent gap in the demographic record. This missing generation forces us to see a galaxy not as a machine of constant production, but as an entity with a dynamic and sometimes interrupted biography. It had a boisterous youth, then fell into a deep, quiet slumber for billions of years, only to reawaken recently to the vibrant star-forming activity we see in its spiral arms today. That silent gap between the ancient and the young stars is the fossilized imprint of that long cosmic nap, a reminder that even the most brilliant islands of light can have dark ages written into their very heart. The galaxy's long silence and the missing generation of stars left a canvas ready to be painted by an invisible artist. Phenomenon 23 is the magnetic field maze, a hidden architecture of force that weaves through every part of NGC 1300. When astronomers map the galaxy not by light, but by the subtle polarization of radio waves, a stunning and complex blueprint emerges. The magnetic field lines are not a chaotic tangle, they form an eerily ordered grid, tightly tracing the grand sweep of the spiral arms and running straight along the length of the central bar. It is as if the galaxy's visible beauty is being traced over by an immense, invisible hand using lines of pure force. Yet this order is not perfect. Within this grid, the map reveals strange kinks, sudden bends, and even places where the magnetic field seems to flip its direction entirely. These are not flaws, but clues to a dynamic and powerful history. These fields are far more than a cosmic curiosity. They are a fundamental part of the galactic machinery. Their influence is subtle but profound. First, they act as a guide for gas. The immense clouds of hydrogen that drift through the spiral arms are not neutral, they are ionized, meaning they are filled with charged particles. Charged particles cannot cross magnetic field lines easily. They are forced to move along them. This means the galaxy's magnetic maze acts like a set of invisible rails, channeling the flow of raw material toward or away from potential stellar nurseries, directly influencing where new stars can be born. Second, these fields are a highway for cosmic rays. These are atomic nuclei, mostly protons, accelerated to nearly the speed of light by supernova explosions. As these high-energy particles race across the galaxy, they bounce and spiral along the magnetic field lines. The maze thus becomes a containment grid, trapping this dangerous radiation and preventing it from simply flying off into intergalactic space. This creates a persistent, low-level background of cosmic radiation that bathes every star and planet in the galaxy, a constant drizzle of atomic bullets from which there is no shelter. But the origin of such a strong, well-organized galactic magnetic field is one of the great unsolved puzzles in astrophysics. We know the basic ingredients, a process called the dynamo effect. As the galaxy rotates, its swirling, conductive plasma of gas and stars acts like a gigantic electrical generator. This motion can amplify a weak seed magnetic field, stretching and twisting it into the powerful structures we observe. But where did the original seed field come from? Was it present in the faint primordial gas that collapsed to form NGC 1300, a relic from the universe's infancy? Or was it generated later by the collective effect of stellar winds and supernova explosions from the galaxy's first generations of stars, a magnetic field built from the chaos of its own early violence? The strange kinks and reversals in the field add another layer of mystery. They could be scars from past mergers, where the magnetic architecture of a consumed dwarf galaxy was spliced unevenly into the larger spiral's grid. Or they might be active sites of magnetic reconnection, where field lines snap and reconfigure in explosive events that release vast amounts of energy, perhaps even triggering those localized bursts of star formation we see. This invisible maze is the galaxy's nervous system, a network of force that connects its past violence to its present structure, silently guiding its gas, steering its radiation, and holding the secret to how order emerges from chaos on a scale that defies human comprehension. That invisible magnetic grid channels energy toward the most unstable objects in the galaxy. Phenomenon 24 is a stellar time bomb, a hyper-luminous blue variable star. This is not just another bright point of light in NGC 1300. It is one of the rarest, most volatile, and most massive stars known to exist. If our sun were a steady candle, this star would be a raging forest fire, burning with a ferocious blue-white intensity that outshines millions of ordinary suns combined. It is a leviathan living on the edge of its own existence, and its violent mood swings offer a preview of the most catastrophic stellar deaths imaginable. A hyper-luminous blue variable is a star in its final frantic chapter. It has exhausted the hydrogen fuel in its core and is now burning heavier elements in a desperate struggle against gravity. This internal turmoil makes it wildly unstable. The star does not simply shine, it convulses. It undergoes colossal eruptions, not mere solar flares, but events where it violently ejects entire shells of its own atmosphere into space. In a single outburst, it can shed a mass equivalent to several of our own suns, creating a vast, expanding nebula around itself. These eruptions are the star's way of trying to stabilize, but they only delay the inevitable. Studying this specific star in NGC 1300 is like watching a cosmic countdown. Its extreme brightness and erratic behavior mark it as a prime candidate for one of two spectacular endings. The first is a superluminous supernova, an explosion so bright it could briefly outshine its entire host galaxy. When such a massive star finally collapses, the detonation is not a standard supernova. It is thought to be powered by exotic physics, perhaps the birth of a magnetar with an impossibly strong magnetic field, or the pair instability process where matter and antimatter creation in the core trigger a total stellar disintegration. The other, even more direct fate is a complete gravitational collapse with no supernova at all. If the star is massive enough and loses sufficient weight in its final eruptions, its core may simply give up the fight entirely. With no outward explosion to halt it, the entire star would implode directly, vanishing from the visible universe and leaving behind only a black hole. The space where a million suns once shone would become a silent, dark pit. This single, twitchy beacon in the spiral arm is therefore a crucial laboratory. By monitoring its pulsations, its temperature fluctuations, and the composition of the material it blows off, astronomers can calibrate the final moments of stellar evolution for the universe's true giants. It informs the ultimate fate of the most massive stars, answering whether they go out with the biggest bang in the cosmos, or with the quietest, most profound whisper into darkness. Its very presence is a promise of future cataclysm, a reminder that within the beautiful structure of a spiral galaxy, individual stars are writing their own spectacular and terminal finales. That stellar time bomb ticks within a galaxy that is itself in motion, a single ship sailing the cosmic ocean. Our final mystery, Phenomenon 25, pulls the lens back to the grandest scale of all, the anomalous proper motion of NGC 1300 itself. We have journeyed through its internal wonders, but now we must ask, where is the entire galaxy going? Precise measurements of its trajectory through intergalactic space reveal a subtle yet persistent drift that does not quite match our predictions. According to the mapped gravity of its local group of galaxies and the broader cosmic flow of expansion, this majestic spiral should be moving in one specific direction at a certain speed. But the observations tell a different story. It is being tugged ever so slightly off its expected course. This is not an error in measurement. It is a clue written in the motion of billions of stars moving in unison, a clue pointing to a presence we cannot see. The force required to deflect an entire galaxy must be colossal, hinting at the gravitational pull of a vast, unseen mass lurking in the darkness beyond. This anomaly evokes one of the great cosmic mysteries of our own local universe, the Great Attractor, a gigantic concentration of mass that pulls our Milky Way and thousands of other galaxies toward it. For NGC 1300, the culprit could be a similar hidden colossus, a gravitational giant lying in what astronomers call the zone of avoidance. This is a region of the sky obscured by the dense gas and dust of our own Milky Way's plane, a blind spot in our cosmic vision where entire superclusters of galaxies could be hiding. Imagine trying to understand the currents of the ocean while a massive island is hidden behind a permanent, impenetrable fog bank. You see your ship drifting inexplicably, feeling the pull, but cannot see what is exerting it. That is our situation with NGC 1300. Its anomalous motion is a compass needle pointing directly into that cosmic fog, suggesting something immense lies in wait. This final phenomenon ties everything together. The strange behaviors within the galaxy, from its quiet black hole to its warped disk, are the internal story. But this unexpected motion is the external story, the tale of the galaxy as a whole being steered by forces on the scale of the cosmos itself. It reminds us that no island of stars is truly isolated. Each is a passenger on a voyage dictated by the invisible architecture of the universe, an architecture built from both the dark matter we infer and the hidden giants we have yet to directly see. The journey through NGC 1300's 25 strangest phenomena ends not with an answer, but with a vector, an arrow pointing from the known into the profound unknown, suggesting that the greatest mysteries are often the ones we sense only by the way they move everything else. NGC 1300 is a single gallery showcasing the entire spectrum of cosmic strangeness, from a silent black hole at its core to the faint ghost arms of its cannibalized past, from stars flung across the void to the invisible scaffold of dark matter that dictates its very shape. This one spiral contains multitudes. It is a microcosm of every major puzzle in modern astronomy, a living testament that the universe specializes in hiding its greatest secrets inside objects of breathtaking beauty. Each phenomenon we explored is not an isolated curiosity, but a connected piece of a story still being written, a story where the physics of the very small dictates the fate of the very large. This single galaxy reminds us just how much remains outside our current understanding, a humbling and thrilling realization that every answer we find simply leads to deeper, more profound questions. We have only just begun to listen to its whispers. Tell us in the comments below which of these 25 mysteries captivated you the most: the dormant giant, the runaway stars, or the invisible dark matter halo. Your curiosity fuels this journey. If you want to explore more corners of the cosmos where mystery reigns, be sure to subscribe and join us for our next deep dive into the unknown.